Hello and welcome back. Today we're going to continue work with a discounted free cash flow model. So in the previous video we had a little bit of accounting review in order to explain why the free cash flow formula looks the way it does. So we found how to compute the free cash flow of a firm for a single year. Today we will use this in order to estimate the value of a firm by discounting its future free cash flow. So again, we take all the cash flows in the future, we discount it until today, just like we did in the stock valuation video. And we're going to do this only with an example. Okay, so just a quick repetition. Sorry. In order to get the free cash flow of the firm, you took EBIT times 1 minus the tax rate. You added back depreciation because it affected the earnings but not the cash. We subtracted the capital expenditures because it did not affect earnings but it's a cash outlay. And then you subtracted an increase in working capital. So this delta here reflects an increase. If it's a decrease, then this would be minus minus and it's a plus. Okay, so like always, we focus on the cash flows. In this case, we focus on the free cash flow of the firm, or FCF. And the enterprise value of a firm is found by computing the present value of all future cash flows. So that's what we're going to do today. And now we have some assumption that the firm will exist forever. Of course, just as with the stock, it doesn't have to exist forever for us to value, like take all future free cash flows. But in the way I will show here, it has to be like it lives forever because I'm using a formula that assumes that. And I'm also going to assume that there's a constant growth after some point. If it only lives for 20 years, that's not necessary, but in my case, it is. And also, of course, we assume that our forecasts are accurate, but again, that goes for everything that we value. But what's very important here, maybe not going to do this in this course, but maybe we'll do it in another. You have sensitivity analysis in order to check for how much would the value depend on your estimations or your assumptions. So maybe we check what happens to the value if we decrease the cost of capital a little bit and increase it a little bit, just to get an idea of how sensitive is our analysis to different assumptions. Okay. When we work with the cash flow of the firm, we use the cost of capital for the firm. And just for notational simplicity, I will tell you that this is called the weighted average cost of capital, and I will usually refer to it as the WACC. So it's just short for the cost of capital, but we use it as any other cost of capital. It's just an interest rate. Okay, so this is the example that we will use. We're looking at a company where we have received the following estimations. So we have estimations for the coming 3 years about how big EBIT is going to be, what the depreciation is going to be each year, how big the working capital is going to be in each year, and what the capital expenditure will be each year. So we're going to value this company, and we received estimates from the management, which we saw in the table. And also, we need to know, like, we expect this company to live forever, because that's one of my assumptions. Then we need to know the cash flows after these 3 years. So here, the cash flow in year 4 is estimated to be 50, and it's estimated to grow by 4% per year from that point. Okay, furthermore, the WACC, so the cost of capital, for the company is 10%, and the company tax rate is 30% in this case. And then, maybe you didn't see that, but we had like a time point 0, that's where we stand today, and the only information we have there is the working capital. So what that means is that today, we already have 50 in working capital in the company. So in the free cash flow formula, we're interested in the change in working capital, not the actual value. Okay. We are now going to estimate the free cash flow for all these 3 years. And we start by the first year. Okay, so here we go. We start by taking EBIT, which you find here. So 100 times 1 minus the tax rate, which we had here, 0.30. Then we should add back depreciation, which we have here. We should subtract capital expenditures that we find here. And then finally, we should subtract the increase in working capital. Okay, so working capital goes from 50 to 60, so that's an increase of 10, which means that there's we should subtract 10 here. And if we compute this, it would be, let's see, 45, if I'm not mistaken. Okay, so then we go into year 2. So we have the cash flow for year 1 is 45. And now we go to year 2 and we do the exact same thing. We take 130 times 1 minus the tax of 0.3. We add back the depreciation of 12. We subtract the capital expenditures of 30. And we check the change in working capital, which is an increase of 5. So we take minus 5. And then this will be 68. And then you can do, as a practice home, you can do it for the 3rd year, and you will find that the free cash flow then is 84. Okay, so now we have the free cash flow for the first 3 years based on these assumptions from the management or estimations. And we also knew that the free cash flow in year 4 is estimated to be 50 and to grow by a constant 4% thereafter, okay? So we could make this in a graph, so this would then be the 1st year, the 2nd year, the 3rd year, and the 4th year, and yeah, these dots just represent that there's something after here. Okay, so what were we supposed to do? Well, we were supposed to compute the present value of all future free cash flows. Sorry. So we can start by taking the present value of 45, the present value of 68, and the present value of 84. So these are the ones that are like odd. And to do this, you know this by now, you take 45 divided by 1 plus the WACC of 0.10 to the power of 1, because we move it 1 year back. Then we add, then we would compute for the 2nd year, 68 divided by 1 plus 0.10 to the power of 2. So this is for the 2nd year. And for the 3rd year, we would take 84 divided by 1 plus 0.10 to the power of 3. Okay, if we do that, we find the present values that are given here. And please, I encourage you to check my calculations. I sometimes make mistakes. And then, if I do, it's good that you find it. Because, well, practice is always good. And it could feel nice to be better than your teacher. Okay, finally, we take the last year. We assume that there's a constant growth forever. So we're going to take the present value of 50 and everything that happens after that. And we know what this is called. It's a growing perpetuity. And the present value of a growing perpetuity is given by this formula. So we can take 50, which is the cash flow, and divide it by the rate of 10% minus the growth of 4%. So the interest rate was here and the growth is here. But as always, we only end up in the year before the first cash flow, so we end up in year 3. So this value, which is 50 divided by 0.10 minus 0.04, is 833.33. Then we need to make another jump back until today. So we take this 833.33 and we take it times 1 divided by 1 plus 0.10 to the power of 3. So it's a jump from year 3 until today. And this turns out to be 626.1. So to get the value of the firm then, it was supposed to be the discounted value of all future cash flows. So what do? Well, we add the present value of all future cash flows. 40.9 plus 56.2 plus 63.1 plus 626.1. And the value of the firm then is a total of 786.3. So what we done now is we went from the accounting numbers for the firm, or the estimations of those. We found the free cash flows, we discounted all of these, and then we found finally the value of the firm. So we want always, or not always, but we might be interested in finding the value of equity. So on the balance sheet, we always have that assets are equal to equity plus liabilities, so equity and debt, basically. For a firm, it's the same thing. The value of a firm is equal to the market value of its equity and the market value of its debt. But what we computed here, when we did that, we never accounted for any cash that we might have in the company. So there might be like a big cash in the bank account of the company. So what we instead computed is called the enterprise value. And the enterprise value is almost the value of the firm. So the value of the firm, it was this market value of equity plus the debt. But the enterprise value is that except for you subtract any excess cash that the company has available. And then if you want to find the market value of equity from this number that we computed, you would simply take or rearrange this formula a little bit. So you would move debt to the left-hand side, and you would move cash to the left-hand side. And finally you get this. So market value of equity is equal to the enterprise value minus the debt plus cash in the company. So that's how you find the market value of equity. All right, to summarize, we had some different earnings measurements. We had EBITDA, which was earnings before interest, taxes, depreciation, and amortization. We have EBIT, which is earnings before interest and taxes. And finally, we have earnings or net earnings. We looked at how depreciation and amortization affects the cash flow of the firm, or rather how to adjust for it if you start from an earnings figure. We also looked at capital expenditures in the same way, and we looked at changes in net working capital, how that affected. That was in the first video. And we ended up with this formula for the free cash flow of the firm. And finally, today we computed the enterprise value of the firm by taking the present value of all future free cash flows to the firm. Okay, and as a final thing, we found the market value of equity by taking the enterprise value minus debt and add back any cash that might be available. All right, so that's it for this video session. Thank you very much.